11.3, vectors in 3D. Guys, I'm not going to spend a ton of time on this section because it's mostly stuff we've talked about, right? Just a couple things I want to point out, just again, to make sure we're all using the same language. We have our two representations of vectors, right? We have the one with the angled brackets, and we have the one where we're adding or subtracting scalars times unit vectors. Can use whichever one you like. Just be careful about mixing the two together. You wouldn't want to put an I inside those angled brackets because it wouldn't make sense. All right. So if you're using the first notation, all you're doing is just basically listing the scalars. If you use the second notation, it's the scalars multiplied by unit vectors, whichever one you're more comfortable with. Again, a lot of times you'll see me use the angled brackets. That's just what I've always used and what I'm most comfortable with. So the nice thing is the vector is going to work exactly the same thing as in 2D. And the reason that's so valuable is because 3D, as we saw, is very hard to draw. It's hard to draw a vector in 3D, but it has all the same properties that a 2D vector does. All right. So, you know, we looked at a slide almost exactly like this for a 2D vector. Adding and subtracting 3D vectors, you just add or subtract their components. A scalar multiple just multiplies across, and the magnitude is pretty much the exact same thing, except now we have that third component in there. Okay, again, it's just Pythagorean theorem. So again, this section we don't spend a lot of time on because we've actually already done a lot of this stuff. We can do a point between, a vector between a point in 3D, just like we could in 2D. And all we do is take our ending value minus our starting value for each component. So that generalizes, and that would be a vector between 0.1 and 0.2. Okay. Now, one thing I do want to emphasize is this vector that we have here is going from 0.1 to 0.2. And notice that, okay, if we do that, then it's x2 minus x1, right? Think of it this way. It's where you're ending minus where you started. If you get that backwards, you'll get a parallel vector just in the 180-degree opposite direction. All right, just all the signs would be backwards. But always think when you're finding a vector between 2 points, it's where you're ending minus where you're beginning. Okay. And if you have a displacement vector where it starts at the origin, well, then the point that it ends at is also makes up the components of your vector. So that's if you have one that starts at the origin. Because if you're starting at 0, 0, 0, you'd be subtracting zeros from the formula above. We still have a unit vector. Find a unit vector the exact same way we did in 2D. We'll be using unit vectors today when we get into dot product. Unit vector has a magnitude of 1. We do the same thing. Sometimes you'll hear the term called normalizing a vector. All you do is you take the vector and divide by its magnitude. Same thing we did before. Just remember, now that it's a 3-component vector, we're taking the square root of the sum of the squares of the 3 components instead of just 2. So everything extends really nicely. What's not easy to do is draw vectors in 3D. So what you guys are going to do today for this section is real quickly, so you know, this is always the default page as you've seen. To do a vector, if you go under here, there's your vector. You can see A, B, C. So you can put in any vector, and you can also define its initial point. Because what you're going to do in the worksheet is you're going to do a graphical representation of vector addition, which, if you remember, that means we put the vectors tip to tip, and then we have that displacement vector going from the origin to the sum of the two. Okay, so that's gonna be something I'm gonna have you guys work on the worksheet. It's gonna be super easy to do in Calculate 3D, and then just like you did last time to get the participation points, save your image, you put it in a Word doc, and save it as a PDF and send it over. All right. So that's what we're gonna do for 11.3. Any questions about that? Seem pretty straightforward? Okay. Like I said, that's why we don't spend a lot of time on it. We spent time on vectors last week, and this is just an extension of it. It's just, we're not going to draw vectors in 3D, but that's what we have Calculate 3D for. All right. Then let's move on to the dot product.